So we are going to go ahead and now solve quadratics by factoring. So we know how to solve linear equations. So basic equations that look like the following, like 6x plus 9 equals 10. So we know how to solve by subtracting and dividing, and we're done. But we want to solve equations now that are called quadratic equations. These equations are of this form. What makes it a quadratic equation is this special number here, this little 2. So when our highest power is a 2, we call this a quadratic equation. So we solve these differently than linear equations because that power 2 is kind of a problem for us in the sense that it doesn't let us use the same steps we use for linear equations. So the way around that is our first step is going to be to factor the quadratic. So when we split the x, the little power goes away in the sense that we don't see it in the equation anymore, but it's technically still there. So let's look at example number 1. We're going to first go ahead and factor this, which means I'm going to do my guess and check. And I'm going to look for two numbers that multiply to x squared, which would be x times x, in this case 2 letters. And then we know our signs are positive. And we're looking for two numbers that multiply to 18, and will give us this 9 in the middle. So that would be the numbers 6 times 3. And if you check it, inners 6x, outers 3x. That's going to give us our 9x in the middle, so it works out. So I've gone ahead and factored this, so we're going to be solving by factoring. My second step now is going to be using the zero product property, which is this right here. Remember, we are asking ourselves what factor times another factor gives me the number 0. So what times what is 0? That means that either the first one is 0 or the second one is 0. So using the zero product property, we can go ahead and solve these. And what's going to make this factor a 0? What number plus 6 equals 0? So my answer is going to be -6. Same thing for the other one, just like we did earlier. What number plus 3 gives me 0? So the number is going to be -3. So my answers are either -6 or -3. All right, for number 2, we're going to do the same exact thing. I'm going to ask myself, how do I solve this quadratic? Again, that power of 2. If I factor it, I just see m and m, which no longer see the 0, the power of 2, which makes it easier for me to solve using the same method we used earlier, the zero product property. So now I'm going to ask myself two numbers that multiply to 20 and will give me that -am once I check it. So I know it's going to be a positive and a negative. And I'm going to be using a 2 times a 10. If I check this, it's going to work out. Inners 2m, outers 10m negative. That gives me -8m, so it checks off. So I'm going to go ahead and now ask myself step 2. I'm going to solve now that I've factored it. Again, I don't see the little 2 anymore. It's easier to solve it this way. So what number would I plug into this first factor? Again, what's inside the parenthesis to make it 0. So what makes this equal to 0 would be when the m is a -2. Same thing for the second factor. What makes m minus 10 equal to 0? That would be when m is +10. It's pretty much just the opposite. Let's go ahead and move on to the last one. I'm going to go ahead and guess and check again. So I'm going to ask myself what numbers multiply to give me 2x squared. And that's going to be 2x times x. I know my signs are positive because everything's positive here. And I want numbers that multiply to 3. That would be 3 times 1. I know if I put it in this order, 3 first and 1 second. If I check my inners, 3x, outers, 2x. That gives me 5x, and it checks off. So I'm going to go ahead now and solve this. So again, these might be a little bit tougher to figure out in your head. So when you can't do it off the top of your head, it helps if you just recopy it, 2x plus 3, and set it equal to 0. I'm going to subtract 3 on both sides. And I get 2x equals to -3. And I just finish it off by dividing by 2. So then that means x is equal to -3/2. And the answer for this one would just be x equals -1. So here are my two answers, -1 or 3/2. That's the first part of our lesson, just using what we've learned, factoring and the zero product property, putting them together to solve quadratics. Now we're going to go to the opposite side of the paper, and we're going to be simplifying expressions with a specific symbol. So we have this special symbol that looks like this. I'm going to highlight it here. So what does this symbol mean right here? You've seen this symbol before, this little plus symbol with a minus symbol. We call this a plus or minus symbol, and it's just a short way of writing two problems in one. So let's look at the first example to see exactly what that means. So when I see 2 plus or minus 6, that means I'm going to do 2 plus 6, or I'm going to do 2 minus 6. It's just a short way of writing these two problems at once. And we can solve each one separately. 2 plus 6 is 8, or my other answer is -4, because 2 minus 6 is -4. That's all the plus and minus symbol means. Let's look at the next one. Same idea, but here I have the same type of problem, but I'm dividing by 5. I notice that both of these numbers on top divide by 5, so I'm going to simplify first before I split it into two problems. 5 divided by 5 is 1, plus or minus. 15 divided by 5 is 3. So this is just 1 plus 3, or 1 minus 3. And if I solve each one, I get 4 or -2. So just going back to the top, here, how many solutions will a problem with a plus or minus have? They will usually have 2 solutions, right? Or 2 answers. Now the second question here is it possible to just have one? And the answer for this, if you think about it, it would be yes. It's actually possible to have one. The only way that's going to happen is if you have like a number like 10, the only number you can add and subtract to 10 to get the same number back is adding 0. So that's the way you can get one solution. 10 plus 0 and 10 minus 0 will both give you 10. Let's move on down to the next problems. Let's look at number 3. Here we just happen to have a square root. Don't let it throw you off. Just solve as usual. So 4 plus or minus square root of 49 would be 7. So this is just 4 plus 7 and 4 minus 7, which would be 11 or -3. The next one gets a little trickier because we have a square root as well, but this one, unlike the one on the previous problem, this square root is not a perfect square. So this is not a perfect square. Second, you are not allowed to divide the 2 with the 40 because that is not a 40. That's really a square root of 40, which is some decimal number like 6 point something or other. So we cannot divide the 2 with a 40 and put a 20 because that would be incorrect. So what we do is we take our 40 and we're going to break it down like we've done before. I'm going to take this and make it a 4 times 10, both inside our radical symbols. And the square root of 4 is just a regular 2. And then we bring down our radical 10. That does not simplify. So I'm going to replace this radical 40 here for 2 radical 10. So I'm going to put 2 plus or minus 2 radical 10. Again, I'm just replacing the 40 for this all over 2. And now I can divide the 2 on the bottom with the 2 on the outside of the radical. So I'm going to go ahead and simplify this. 2 divides the 2 on the left, gives me a 1. 2 divides the 2 on the right, which gives me a 1 as well. Radical 10. If you don't want to put that second 1, you don't have to. It can be an invisible 1. Let's move on to number 5. Same thing as before, -5 plus 10 and -5 minus 10, which gives me +5 or -15. Number 6 is very similar to number 2. The 3 divides into the 3, the 3 divides into the 6, but it's negative. So we're going to get -1 plus or minus 2. And it's technically a -2, but if you multiply the negative with the plus minus, you still get a plus minus. So -1 plus 2 gives me 1. -1 minus 2 gives me -3. Let's move on to the next problem. We'll clear this out real quick and scoot it down so we can see it nicely. All right, let's go to the next one. Square root of 81. That's a perfect square, so that's going to be -10 plus or minus 9. Let's just kind of do it without writing it all out. What's -10 plus 9? That's going to give me -1. -10 minus 9 is -19. On the right side, we have radical 24, just like the problem above it with the 40. inside the radical, we break it down. 4 times 6, that's 2 radical 6. So I'm going to replace this radical 24 with 2 radical 6, and I'm going to divide like I did in the previous problem. 2 plus or minus 2 radical 6, and I'm going to divide by 2. That's going to be 1 plus or minus, I'm going to make it an invisible one this time, radical 6. But you can write it if you like. And for the last 2 problems, square root of 18, again, another perfect square, a non-perfect square. So the 18 will break down into 9 times 2, which brings down to 3 radical 2. So I'm going to replace the 18 for 3 radical 2. Now, I cannot simplify this, so unless I use a calculator, so I'm just going to leave it as is. And the last one, we have another square root. Although this one is a perfect square, so I'm going to divide it out nicely. So it's going to be 3 plus or minus 12 all over 5. But in this case, the 5 doesn't divide into the 3 or the 12, so I'm going to have to do it the longer way, which means I'm going to split it into both the plus and the minus. I just don't have room in the bottom, so I'm going to write it sideways. 3 once with the positive and once with the negative. And I figure each one out separately. 3 plus 12 is 15, divided by 5 is 3. 3 minus 12 is negative 9, divided by 5. It doesn't simplify, so I'm just going to leave these as my answers, 3 or negative 9 over 5. And that's the general idea of how to use a plus minus with like division, square roots in there, how to simplify. Now it's your turn to go ahead and practice. Good luck.